Okay, now let us turn to equivalent fractions. Two fractions are said to be equivalent if they have the same value, i.e., if a over b is equivalent to x over y, then a over b is equal to c, and x over y is equaling to c. So that's the idea. When we insert the fraction, this one gives you the same value as this one, then those two fractions are equivalent. In equivalent fractions, both the numerator and denominator can be multiplied by 2, or, can be multiplied by the same number, or both can be divided by the same number, as we are going to see here. So I'm going to give you some few examples, then you try out the examples in our or in your learner's guide. So this one says, find equivalent fractions of the following. So they are saying at least 2. So I'm going to give at least 2 for both, for the 3. So now, if I turn for the half, I want our equivalent fractions for half. I can say 1 over 2, I multiply up by 3, or I multiply also down by 3. So this one is going to give me 3 over 6. So this one is equivalent to this. I can get also a half over 2. I multiply this side by 4. I multiply this side also by 4. So this will give me 4 over 8. When you place this on the calculator, it's going to give you the same answer with this. So here the equivalent fractions are 3 over 6, 4 over 8, you can give other. So these ones are equivalent to this. When you press this on the calculator, it's going to give you the same value when you press this on the calculator. Well, that's what we are talking about. When you get to this, the value here is going to be the same value as you get there. So let us come to this. You can choose this one, you can choose 2, you can choose 5. It's your own. It's not defined that you have to use this and this. So you determine according to you. It depends on what you have, what can you use. Okay? So when I come to this one, now we are going to say 3 over 5. Now let me multiply here by 2. Let me multiply here by 2. This is going to give me 3 times 2. That is 6 over 10. So that's 1. Then I can say another one is 3 over 5. Let me multiply by 3. Let me multiply by 3. This is going to give me 9 over 15. So here it says, for the equivalent, I have first of all 6 over 10, and I also have 9 over 15. Try more. So now this one, we said you can also divide. Now one of the first equivalent fractions here, for 8 over 14, you see you can divide by 2, both sides. So we divide by 2 here, then you can divide by 2 here, which will give you 8 divided by 2, you get 4, and here we get 7. So this is equivalent to this. You can also decide from here, you can multiply by 3 to be as simple as that. So I'm leaving that to you as an exercise. So the first is 4 over 7. You can add here, then also add from here another, then in there. So I'm leaving you with this, so you can try out that one. Okay, let us see now operations on fractions. This involves addition, subtraction, division, and multiplication. You can also use body mass, as you're going to see. So find a third of this. In body mass, I think very out. Sometimes we call this one as an operation. Close to it must Actually, it's going to be of, and you said of means multiplication. Okay, so this is the same as a third, where it is of, replace multiplication sign, 9,000. So if they tell you get a third of the 9,000, this is what you do. So this times that. So that is that this one is going to give us 9,000 over 3, which is going to give us, goes there, 3 times, as simple as can also handle this. Okay? But you can see here, you now skip this step by saying this one, this 3. 3 times this, that's what it will be. It will be the same. So this will be also 2 over 5 times 20,000. Same by this now, by this 4. So instead of half 2 times, okay, half 2 times 4,000, which will give you 8,000 with this. So you have finished that. Now, I'm leaving you with this one. You see, this one is a mixed number. So, you try out that in your free time. You first convert to improper, then you simplify and see. Addition and subtraction of fractions with the same denominator. If we add or subtract fractions with the same denominators, then you see you first check denominator, this is the denominator, this is the denominator, these are numerators. You first check if they are the same. If this one is the same as this, then what you do, you get that denominator, then you do what the sign is telling you to do to the numerator. So you say this is going to be a plus c, the all over a common denominator or the same denominator. The same happens if you come to subtraction. You see this and this, they are the same. So you get a minus c, the numerators over the denominator there, as you are going to see. Let us see some examples there. In our examples, we have this one. We first check, are the denominators the same? Do you agree? Do you agree that first of all, the denominators, we have this and this as the denominator? This and this as our numerators. Are they the same? Are they the same? Okay. So what happens? We use the approach. We say this is the same as, we get the same denominator. Then what happens? What should I put up? Then plus minus. Plus y. Okay. Someone is saying plus because it's the operation we are using. Then the 1. So this will give us, when we add here, 3 plus 1, 4 over 5. Can we reduce that number? Can we reduce that fraction further? No, because there is no any number which can divide this and the other one which is down, so we can leave it at that point. Okay, let us handle the second one down. The second one we have, this is going to give us, is the numerator the same? So we have 3 and 3. So what we do, this is going to be 3. Get now 8 plus 2. It's going to give us 10 over 3. Can we reduce? Is there a number which can divide this and this? No, we should always give them to the simplest fraction or to the lowest fraction. So it's that we can simplify, so that is how far we can go with that. Let us see this now. The denominator is the same, so this is going to be now, say we get 8, then we get 5, the operation, then 3. This is going to be 5 minus 2, 5 minus 3, okay, someone is saying 2 over 8. Now you look at that, can we simplify it? Is there a number which can divide this and this? Which number is that? 2. Okay. By 2 goes into 2 how many times? 1. Okay. What about in 4? 2 goes in 4 how many times? Okay. That's how we can simplify that. We always give to them. Simplify. And see that something can divide both. We always simplify there. What about this one? And the denominator is the same. You first check that. Someone is saying yes. What is the common denominator? It's going to be 7. Okay. Then what happens? You get now 6 minus 1. Because it's the operation we are dealing with. So this will give us 6 minus 1. You get 5, the whole over 7. And that's going to be our answer there. I think, can we simplify? Is there a number which divides this and this? Are they having a common factor? I think no. So we stop at that. Now, this one I'm going to try it as in groups of 10, 10. Can you separate 10, 10? Work out the fraction represented by the shaded parts. So I want you to hand now this for me and this for me. Hurry. I'm giving you, this one is very simple, 5 minutes. Each group represent, I'm going to use only one group randomly. So I should find me the work as I move. Okay. Okay, let me use group 3. Our means overlaps. Can you extend the work? Extend the work to the neighboring group. This group you give to the other, and then the other gives to you. Then you give to these ones, then they also give you theirs. Okay, so this is what group 3 are having. I'm going to hand number 1, then we see what happens to number 2. So this is what group 3 are having. This is their presentation. So I think you can able see. So what they are doing, for them they say, they first simplified the fraction. They told us that, as you can able see. So they told us that this one, the first one, is, they told us that this one is 1 over 3. Is it 1 over 3, as we saw? So how many do we have? 1, 2, 3. How many do we shade? 1. So it means that because we wanted to work out the fraction represented by the shaded parts. So this was 1 over 3, as you can able to see. Okay. Is your group having, is the other group having the same? Yes? Okay. Let us go to, now they have this as, you start 2 parts were shaded out of the 3. So they have 2 over 3 for this one. And then, so this is what they are having. For them, they are saying this is the same as, here it is a 30, then plus, here they shaded 2 out of the 3. Okay? Then what happens? Is that group having the same? No. What are they having? They interchanged them. So they have this, and then this one. Okay. Then here, I think we come in now back to what we've been seeing there. So, the same, is the denominator the same? I think you see how they worked it out. They saw that the denominator is the same. So this one they did 3, then they had 1 plus 2, which gave them 3 over 3. Is there a number which can divide those two? I think you see what they are having. They are seeing 3 can divide both. Divided by 3. Or you can able just say 2 divided by 3 is giving us a 1. Okay. So how many groups are having the same answer like this one? Okay. How many? Can we correct that? Okay. So I think now you know what we are going to, you know what happened to theirs. Is there another group? Okay, let me use another group. Anyway, try now. This one is going to be, now everyone, you are going to do this number in your books. Then you bring it to me, and this number, then you make your own notes about this. Then we see what happens there. You present that one to me after here.